All right, thank you for joining everyone, and thank you for your patience with the Zoom presentations. So what I was going to talk about today was 4 things, not in great detail, but enough to get you to think about how to identify them and where to find more information. We'll start with bacteria blight, move to rust, then to white mold, and very quickly talk about soybean cyst nematode. So throughout the presentation, I'm going to give you some resources that you should be able to access online. And most of the time in the presentation, you'll see the website that you can find them at on top. But often, like this, the Dry Edible Bean Diagnostic Series, you can just Google it and it will usually take you to it. So, and this is the first thing I'm going to talk about. So diagnosis is really important. And one of the things that we tried to create in the last couple of years was a pocket guide that was high quality and specifically designed for diseases that we see in North Dakota and Minnesota. And so this is in front of you, and you can see on the left of your screen, you've got a title page, and then you've got an index, and it's separated into root diseases, stem and wilt diseases, and foliar diseases. And then on the right side of the screen is a sample of what these cards look like. And so we designed them specifically for identification. So you can see the front of each of these cards, and they come in a bound ring. The front of each of the cards is just photographs. And then the flip side of that card is just information about what it looks like, factors favoring development, and maybe when and where you'd find it. So I would encourage you, if you don't have one of these, they're available. They're available at this website, and some of the county extension agents will have quick access to some of them as well. All right, so the first thing I'm thinking about this year is bacteria blights. And part of the reason is that we saw a fair bit of bacteria blight last year, and we know bacteria blight can survive on the seed. And of course, we always recommend you have clean, certified seed when you plant. Sometimes that doesn't happen, but bacteria blight also survives in residue. So given the environment that we had last year with a lot of water and a lot of bacteria, we probably are going to see bacteria blights show up. And seed is one of the sources I'm concerned about, but residue can affect anyone. All right, so for conditions to see bacterial blights, you really need storms. You need that infection source first, whether that's seed or residue from previous year's crop, neighboring field, etc. But when you have thunderstorms, you have damaging winds, hail, things that will tear the tissue of the plant. Not a lot, just enough. You will have a recipe for bacterial blight. And that's because the bacteria is almost always there. It just needs water and it just needs leaf damage for the infection to occur. When you do see it, you tend to see, and this is common blight, but you tend to see infections starting on margins with common blight, or it can be chlorotic and necrotic inside the tissue. There are images of the way these 3 different bacterial blights look. I'm not sure that that's particularly important to tell them apart. They generally look chlorotic and necrotic, and they generally have little water-soaked lesions on them. That's typical of bacteria. So this is a photograph that I took a couple years ago, and common blight had come in after a storm, and it was pretty heavily damaged, and the edge of the field looked like this. The inside was going to be infected in the next storm, would be my guess, but the complete edge that was close to residue looked like this. So here's a little bit of the water soaking that I was talking about. And so this is a pod, this is a fairly small pod, and you have these lesions that look like maybe they're drops of oil or something on the healthy green tissue. And then in the center of some of them, you see ooze, and that's the bacterial ooze. So all 3 of these bacterial blights will look like this when they start. They all have that kind of shiny oil drop appearance. Very different than something like a rust. So later in the season, when you see them on the pods, bacterial blights will look like this. You can see some of the remnants of that oil dropping look on some of those pods, but these lesions will get a little bit deeper. They'll get necrotic, and they'll damage the pods and the beans inside. Okay, so managing bacterial blights. This is difficult. Once they get going, it's really hard to manage them, and quite frankly, in our environment, it's hard to manage them in any situation. But what I'm putting in front of you is a data table or data results from a series of experiments that we did a couple years back, looking at bacterial blight severity and a whole bunch of different treatment options. So the treatment options here are on the left of the screen. The rates that we applied them are right next to it. And these were applied multiple times for the most part. Most of the time, they were applied twice, okay? So there was 3 different locations that we looked at: Fargo, Prosper, and Oaks. So these were all on NDSU experiment ground here, and they're organized by disease severity. So the average, the severity over time, is the far right column. So the non-treated is the first one. So in the non-treated experiment, 73% of the tissue was damaged. It's quite severe. And then you can see as the number gets lower and lower and lower, there's less damage. So these products can work, and you have the data from these 3 different trials in front of you. But we had very little relationship with yield. And in this particular year, Fargo got rust, Oaks got white mold. There was just a lot of damage all around. So there's more information available at this Crop and Pest Report article from 2017, and the link is up there. Early in the season this year, I'm going to take a look at this and some more data that we did after that, and put that into the Crop and Pest Report to make that available. The message I really have here is that bacterial blights are hard to manage. This is the results after 2 applications. It's a challenge. The best case scenario is to try to prevent them in the first place, clean seed and hope the weather turns. But there is information about some of these if there's more interest, and you can find some of them up top. And like I said, I'll put it in the Crop and Pest Report early in the season. The next disease I was going to talk about was rust. And so I've been fairly concerned about rust for a while. So I'm going to take you through how rust works and then talk a little bit about management. And one of the first things I would say is that rust is very specific. So rust on dry beans does not go to sunflowers or wheat or vice versa, but they all act the same. And so this is a photograph that I think really helps explain how rust works. So you see this is a sunflower leaf, and this particular sunflower leaf was facing the sky. It was horizontal to the ground, and it had a little depression in the leaf itself. And when you have that, you have more wetness, right, in that depression, and that's what rust needs. Rust doesn't need rain. It doesn't need thunderstorms. All it needs is frequent leaf wetness. So usually the worst rust that we see is with heavy dew, it's fog, it's a dense, thick canopy, it's maybe close to a shelter belt. It's really all about the leaf wetness. And rust actually shows up more with warm temperatures. So it's very opposite white mold. You don't often see white mold and rust in the same field. White mold likes it cool and wet, and everyone knows that. Rust would prefer it warm and on the dry side, as long as it's got heavy dew. And again, the rust is specific to dry beans, so you won't see this rust move to your soybeans or anything else. Rusts are very specific. All right, so when you see rust, when you actually are in a field and you see it for the first time in a season, you usually see it as hot spots. And so these are a series of photographs I'm going to show you of a hot spot from a few years back. And so I got a call from a consultant who was in a field, and she said, I found rust. It was on the shelter belt, which is common because there's more wetness. And so we started scouting this field, and this is a typical hotspot that you might see. So you can see in the middle of the screen, it's really difficult to see, just a little bit of yellowing maybe on the leaves. But as you walk in, you can start to see that there's a fair bit of rust there. And part of the reason it's difficult to see is the severity of the rust is really high on the bottom of the canopy, not necessarily the top. Once it gets to the top, then it'll spread to the whole field. But usually the hot spots are in the middle of the canopy, and that's because you have better conditions for it to develop early. You've got more dew. You've got a thick canopy. Those lower leaves remain wet longer. Here's a picture from 2 years ago in the Devil's Lake area. So this field, this is getting close to the end of the season, but parts of this field were defoliated by rust. It was really pretty ugly to see, and a situation that we don't want, but it can and will happen sometimes. So here's a few close-ups from that particular field. The plant on the left has some leaf tissue left. That's actually more leaf tissue than most of the plants, but it's very covered up with rust. Same thing with the pods. You've got pustules on those pods. And you can see the pod is really shriveled up, and that's because of the rust. All right, so managing rust. So rotation helps. It's not perfect, it helps. But rust can blow around, right? Bacterial blight blows around a little bit, but rust can blow a long way. So rotation is a little less effective. Genetic resistance is awesome when it works, But most of our varieties are susceptible right now. That's because the pathogen changed not that long ago. So fungicides become very important. So fungicides are also very effective. So that's a very good thing. Timing of fungicides really is dependent on scouting. You don't need to spray preventatively. And say once pintos start to stripe, you don't need to spray anymore in the season either. Scouting is important though. And so what I usually recommend is if you have a leaf wetness event, usually in July, maybe anytime after the 4th of July and your beans start to canopy, you need to get in there and start to look for rust. So after a couple really heavy dews, once that canopy gets close to closing, you're probably going to see rust in 7 to 10 days. All right, so if you're thinking about pulling the trigger, scouting is important. And I know a lot of folks will drop in a little bit of extra chemical of something else into a white mold application. That can help keep rust at bay for some time. All right, the last thing about fungicides is that multiple chemistries can work. And so here's a couple different trials that we did over time. And so here's 2015, and you're looking at a rust fungicide trial severity. So on the left, you have a bunch of different products. You've got Endura up top. The non-treated control is in a yellow bar. And then you've got all these other products that we have applied. And you can see there's quite a few of them that work. In general, the strobilurins and the triazoles work the best. So something that has a QOI or has a strobilurin chemistry headline, Priax or Quadris, things like that, they work pretty well. Or something that has a triazole, so that would be a generic Folacure or many of the other ones, Proline, things like that. On the bar here, you can see rust severity, and you can certainly see that the non-treated control has a lot of disease severity. Endura, great on white mold, not as much on rust. So they're statistically the same here, but sometimes Endura works a little bit. Here's 2016, same thing. So we have another epidemic, and these are on NDSU's campus where we can put the spores down and not interfere with any production. And you can see the rust severity of the non-treated control, and the yellow bar at the bottom is 25%. That's a lot of rust. And again, you can see that these products are working pretty well. The ones that don't work as well are the ones you might be tempted to spray for white mold, Tops and Endura, for example. Okay. So QOIs, strobilurins, pretty good. DMIs, the triazoles, pretty good. Some of the SDHIs, okay. But there's products out there. And again, I will put this also in the crop and pest report so they'll have more information as the season progresses. All right, so let's switch to white mold. So with white mold, we have a lot of sclerotia out on the ground right now. It's under snow if you're unfortunate enough to still have snow. It's on the soil, it's tilled in the soil, it's out there. And so these are the black structures of the pathogen, and that's how they overwinter. And they're tough, they're robust. And this is just a handful of seed and sclerotia I grabbed one time when I was in a field. All right, so when the sclerotia are in the soil, if you have water before bloom, these will germinate and produce these little mushrooms, okay? So the sclerotia are the hard black structures. You get water before bloom, and usually 1 to 2 inches, 1 to 2 weeks before bloom is kind of the critical minimum. Anything more than that, saturated soil is going to push these things to germinate. They produce the mushrooms, which are the apothecia, and then those things release the spores. Here's some apothecia that I found in some residue a few years back. Okay, once that happens, once those spores are released, they will go into well, not really the atmosphere, but they'll get up above the canopy and they'll float around, they'll blow with the wind. And if they land on flower tissue, they'll start the infection. So this is kind of the weak spot, right? So you have these spores floating around. They're not really going to infect healthy green tissue. They need that blooming tissue. They need those florets. And so I'm showing you an example here of a sunflower field. And so I'm in the sunflower field, I grab the sunflower leaf, there's this little floret on the sunflower leaf, and you can see that a spore had landed on that, started digesting that flower, and then it spread into the healthy green tissue. And that's the way it works for all of these crops. And unlike rust, every broadleaf crop we grow in North Dakota is susceptible to white mold, and it's the same white mold. So if you have white mold in dry beans, soybeans, sunflower, canola, it doesn't matter, it's all the same pathogen. So rotation helps a little bit, but not a lot. Every broadleaf crop we grow is susceptible. For this infection to happen though, it needs to be cool and wet. and I think everyone is aware of this. You know, you're in the 60s or low 70s, you get frequent rains during bloom, you're at high risk for white mold. And of course, once you get the infection started, it's going to spread. And so here's a couple of pictures of dry beans, and you can see on the right, the plant is dead now at the end of the season, and those black structures are sclerotia everywhere. There's been a lot of discussion about plant-to-plant spread, and absolutely that can happen. So this is a picture of sunflowers, and sunflowers are so big, it's really easy to see the plant-to-plant spread happen. And you have a stem here that's got an infection, and the neighboring plant had a leaf that touched that infection, and it basically stuck there. And that infection started and progressed into the healthy one. So when you have a field that has white mold that stays in the field for a long time, especially if it's wet, this will spread plant to plant. But to manage it, we really need to focus on the early bloom stage. All right, so managing white mold with fungicide. So we have some resources for you, and I'll show you them. The general overview is that, you know, favorable conditions in the bloom stage are going to be really consistent with your timing. So you think early bloom, or when the canopy closes, if it's cool and wet, you're probably going to think about pulling a trigger. Efficacy is important. You don't want to cut rates. There is a rate effect in a lot of the products we use, but multiple chemistries are effective, and I'm going to show you some of those. And you can look at this and a lot more information at the Carrington REC website that Dr. Michael Bunch has got. So this is a picture of the website. Once you get to Carrington, you click on plant pathology. So you've got plant pathology on one tab, and then he has PDFs of all of these outreach talks. And there's a lot of information about white mold, and it's not just dry beans, it's soybeans, it's sunflowers. There's a lot of information here, and I encourage you to check it out for more detail. All right, so one of the things I'm going to show you here is just a comparison of fungicide efficacy, and I'm going to try to take you through this. So if you look on the left side of the screen, you can see the product tested here is Endura at 8 ounces, and it's compared to the non-treated control. Okay, so pretty simple, one-to-one comparison. But this information is made up of 12 site years of data. You can see underneath the severity, there's a thing that says 12 site years of data. So this pretty robust data is the message here. The first column is the Sclerotinia severity. Okay, so this is high disease pressure. So Endura, and in this particular case, Endura was applied twice. Endura had 19% severity compared to the non-treated, which is 48%. So that's a 60% reduction in disease severity. And here on the right is the yield. And you can see Endura, over the course of all these 12 years of data, it was a 30% increase in yield when you put down Endura a couple of times under high disease pressure. I want to emphasize that. This is somewhat artificial because it's really high disease pressure, but it's great for proof of concept. Do these things work? Here's the same type of data with Topsin at 30 ounces. You can see it's very similar. Topsin at 30 ounces is kind of the mid-rate, and it's very similar in disease reduction and very similar in yield protection. Same thing with Omega, same thing with Propulse. Okay, so I would emphasize here, you can take a look at the data on the website, but I would emphasize that this is high disease pressure. These are 2 applications, pretty intense. And I think in a really bad year, this is probably what you would see in the field, but most years we don't see this level of disease. We just don't, but the fungicides can help protect. The other thing I was going to show you is that there's a rate effect. And so here, this is set up the same way. So in these particular trials, Michael has taken Topsin at 30 ounces compared to the non-treated, and Topsin at 20 ounces compared to the non-treated. And there's differences in severity and yield. And I would just point you to the right side of the screen. Topsin at 30 ounces over the course of 10 years of data, it really protected quite well, 2,700 pounds compared to 2,000. But at that lower rate, there's only 2,700 to 2,500. Again, Topsin's a good product, but under high disease pressure, there's a distinct rate effect. Same thing with Propulse. Without going into too much detail here, you also see that. And this is a difference between 10.3 and 8.6. So that's not really a huge difference, but you even in that amount, you can see the rate effect. So in particular with Topsin or T-methyl, you probably, especially under high disease pressure, stick with that mid-rate or higher. There's another tool that's available online. This is the Sclerotinia risk map for canola, and the website is on top of the screen. And you can access that. So I pulled a screen capture image of this from the 4th of July last year, and red indicates it's high risk, and green indicates low risk. And you can see most of the state was at fairly high risk for Sclerotinia. So this is based on pathogen biology. So this is applicable, broadly applicable to dry beans, soybeans, sunflowers, etc., once those plants are in bloom. All right, the last thing I wanted to mention, and this is probably just a minute here, is soybean cyst nematode. So one of the things that you might see this year, you might want to think about, is soybean cyst in your dry beans. It's a parasitic worm. It is moving through our dry bean production area, and it can cause some yield loss. So here's a photo, a couple photos from a kidney field. This is on the Minnesota side of the river, but we do know this can cause some damage. Okay. The one thing I wanted to say about SCN is towards the end of the season, you might want to consider sampling for SCN to see if you have it in your field. And this is these are 2 cards from that dry bean diagnostic guide. It's the same set, same website up top, and there's information about SCN and information about how to sample. That right card is all about sampling. And that's all I have for you.